particular presentation is actually a little bit more technical in nature at the request of Jim. I know in past it's always been just a general product overview, history of Watson McDaniel, and then just taking a look at our whole product line. So at our core, manufacturer of steam traps, regulating valves, and condensate pumps, among other things when you start getting into ASME certified skid systems, so condensate recovery systems, flash tanks, instantaneous hot water heaters. Still doing all those things that we've talked about before, still doing all those things today, and then more, because Watson's always evolving, so I think every week there's always something new. Which probably brings me to introducing Mark. Some of you may be familiar with Mark from probably when he handled IPS a while ago, and then it kind of transitioned to Joe Prindable, then tag team between Joe and I, now tag team between myself, Joe, and Mark. So once again, always evolving, just trying to recognize what the marketplace needs, and I think in this Northeast territory it was decided that more representation was needed, more help, whether it be doing things like this, going out, making calls with your customers, hitting the engineering firms, really whatever it may be to promote the Watson product line. So I'll just let Mark do a quick introduction, since it has been a few years maybe since he's been around.
Yeah, I handled your account. I mean, I think you're probably the only person I recognize out of anybody. Were you around 10? What? Mm-hmm. You look slightly familiar, just 10 years older. Yeah, but I was around from like 06 to 2009, 2010, and then I ended up coming back in 2013. So I've been with Watson for almost 10 years now at this point. But yeah, so I kind of handle the other parts of the Northeast that Steve doesn't, and like he said, we're more or less tag teaming Eastern Pennsylvania, Southern New Jersey, Northern New Jersey. So really we're just going in more of a team effort. One of the problems we had, which doesn't really affect you guys, but he was handling certain distributors, I was handling certain distributors. We were doing the same thing and then meeting in the middle, and that's not good. So now there's just more communication, so we know what we're doing and we're not stepping on each other's toes out in the field. So it seems to be working out.
So your first point of contacts really should always be myself and Mark, especially on the commercial end of things. Joe Prindable, Monday through Wednesday, is essentially in the office answering our engineering calls that come in from across the country. So it may be a little bit harder to get him on those days. But then certainly, Thursdays and Fridays, he's unleashed, he's out in the field, he's with customers. If there's any troubleshooting calls that Mark and I can't get to, we're sending Joe out there. You're obviously familiar with that. What I would ask is, if you do run into any commercial issues, I mean, I know a hot topic is the returns thing. If you could pull us in, maybe up front. Unfortunately, it should be done at our end, but if you guys can kind of take that little bit upon yourself, because I think you'd find a little bit quicker resolution once you start getting us involved. And that's what you guys deserve on that stuff anyway. So I'd like to be put in up front on that kind of stuff.
And then I guess just continuing on that, you guys know that Lori is your dedicated inside salesperson. Any kind of pricing and delivery type stuff, you can come to us, but we're probably on the road. If you want a quick answer on pricing and delivery or status on an order, just give Lori a call, shoot her an email. She'll be able to help you out pretty quick.
So like I mentioned, we're gonna dive in and just look at steam traps today. Certainly this is meant to be an open discussion. If you guys have anything else that you want to talk about, even if it's outside of steam traps, feel free to holler it out. So real quick, we're going to take a look at the different types of steam traps that Watson McDaniel offers and how they operate, how they function in the system. Go through some of the different sizing and selections, taking a look at the differences between drip loads and actual process loads. Talk about where these traps are discharging, whether it's atmospheric or maybe you have some considerations for back pressure, that all go into sizing and selecting a proper steam trap. And along the way, because we know you field a lot of the calls and maybe even some of the more crossover type calls, we're going to try to, now while it's not in the presentation, we're going to try to think of some of those trigger words you might hear. So, hey, I want a Sarco TD52 or a Cool Blue. All right, well, you're looking at a Watson McDaniel TD600. So we're going to try to throw some of that stuff in. And we do have some samples to kind of guide us through that as well. So we take just a overview look at our steam trap offering. Certainly we have all the core offerings there. So you've got a thermodynamic or a disc style steam trap. You've got a thermostatic bellows style steam trap, floating thermostatic, often referred to as an F&T trap, and then your inverted bucket trap. When you look at the territory that your team covers, what would be some of the more common steam traps that you get asked for? You hear, I heard it. I mean, inverted buckets earlier was one that came up.
F&T.
F&T
Yeah, I was
a
gonna
lot.
say F&T.
I'm curious, like thermodynamics, is that something that you come across often, or like as a drip, or do you find most people just trying to standardize on like an F&T and just making sure the pressure range meets there?
I mean, we get them, but the F&Ts, we just sell them all.
Okay.
I think, because you guys were the TLV rep back in, whatever, early 2000s, and they probably sold a ton of free floats. I'm assuming that's why people kind of stuck with, even though they're going with Watson McDaniel, it's not exact free float, they're probably used to using an F&T, and they just kept using it. Sure, probably what happened.
Okay.
And this, just see, this can get overwhelming and kind of looks like, oh, I have to know 50 different products. No, you're gonna sell that. You're not gonna sell any of these, I guarantee it. You'll sell maybe these, that, not that, not that, not that, probably. You'll sell this if you're replacing a bucket, this for higher capacity heat exchangers, and here, these are just different sizes because of pressures or capacities. So it can look overwhelming, like, oh my God, I'm gonna have to remember all these model numbers. It's literally, you'll sell one of these, you'll sell two of these. So don't let this kind of bog you down. Just when you hear floating thermostatic, 95% of the time it's gonna be this. The other times it's probably gonna be that, which is bigger for heat exchangers and air handling unit coils and stuff like that.
Yeah, obviously to round out our steam trap offering and compete with all the manufacturers out there, we have to have the breadth there to offer. But Mark's absolutely right in that you really kind of focus on, a few here and there.
Yeah, I'd rather you guys really understand the 5 main products, and then if you get a call for another one, just give us a shout and we'll help you out.
Yeah, I mean, even one that we don't even show here would be a bimetallic type of steam trap. If you start getting into superheated steam, and well, there's some of these that can handle some superheat, but excessive superheat and things like that. So different types of applications when talking about steam traps. One of the most common is going to be a drip trap. So getting all the air, non-condensable gases out of the system to have your most efficient steam possible, driest steam in the system. That's what a drip trap's going to help do. And we'll talk about where you see those types of traps and what traps, as a general rule of thumb, we recommend. Tracing applications, which I think in previous presentations, I'm not sure was a big thing out this way. So using steam tracing to maintain certain product temperatures, maybe you're offloading on a rail car some food oil or something, comes as more of a solid form, heat that up, run it through piping to a storage tank, so you want to maintain that viscosity, so you're going to use steam to trace that product line, or even to keep certain components within a system warm and hot during the winter months.
I think most of what you do out here is like a lot of food and beverage, and it's all indoors, so you don't really typically have to worry about that.
Does tracing sound familiar at all, or not typically?
It's not typical, but yeah.
Okay. I mean, we'll touch on that briefly. It's pretty easy actually to understand, so there's not a whole lot involved there. And then, of course, the process applications, heat exchangers, jacketed kettles, the things that you guys see probably every day or hear about every day. So when looking at the different types of traps, so we'll start with the thermodynamic disc trap. Very simple in operation and design. It's got one moving part, the disc inside that top assembly or underneath that cap. We'll point to Mark here. He's going to talk a little bit about how they operate, just so you have a little bit more background.
So this is the same thing. This is a traditional TD trap. The cap's just too tight, so I can't take it off. But here's what it looks like inside. So you have your cap, you have your disc, you have your holes in here, your middle hole where the condensate comes in, and then the 3 holes on the outside where the condensate leaves. And basically all it's doing is condensate comes in, pushes the disc up, And because you're coming from a high pressure steam system to a lower pressure return system, have you guys heard of flash steam? So hot condensate goes to a lower pressure area. You get a little bit of flash above the disc, and that little bit of flash causes the disc to go closed. And then it cools down again, condensate hits it, goes up and down. There's some other things happening. There's increased velocity across an orifice, which causes a pressure drop, and it's like Bernoulli's principle. Below the disc, it kind of causes a suction where it kind of pulls the disc closed. But virtually, this is just an on-off trap, so it's either fully open or fully closed. It's not like an F&T where it's going to modulate inside. Very good for drip applications, good for tracing applications, not good for process applications. We see a lot of times people have a heat exchanger or a jacketed kettle, and we see a 1-inch TD trap on the bottom. Like, oh, well, we sized it, it had the capacity and everything. That's great. These are not good for venting air. So on startup of a process piece of equipment, it's going to take a long time to get that product hot. It has a cyclic discharge, so it's on off instead of modulating to get rid of it as the condensate's formed. So a lot of reasons why they're good, some reasons why they're bad. They're also good, they're very small, and they're pretty inexpensive. So on a drip application, you'd rather put this than some bulky, gigantic inverted bucket trap. Also, this can be mounted literally in any position. So it doesn't care if it's sideways, upside down, or whatever.
Right. And certainly, you know, by putting it in the vertical would make it freeze-proof if you have any considerations for freezing and outdoor temperatures. When you look at some of the different, you know, when you go across the product offering here, Mark did mention that our TD600 is going to be the most common one. So, you know, like I said, TD52 or Full Blue or the Spirax Sarco would cross over to, you know, the Watson TD600.
This is the Sarco version. This is the Watson McDaniel version. So I'll send those.
We still utilize the all bar stock 420 stainless steel, so we feel like you're getting just a better quality piece at even a lower cost point. You may have heard, you know, maybe a Sarco TD42. All right, now I want to add a strainer or even a blowdown into that thermodynamic trap. That would be the TD600S for the strainer, or SB, strainer and blowdown. All of these traps, really, until you get to the 900, are going to be rated up to 600 PSI, so certainly going to fit within the facilities you're in. Now, those two, not really meant to be repairable. While there are folks that like to refurbish them by getting a disc kit or something and trying to clean up the seat, they're really meant to just be throwaway type of traps. If you have someone that likes that type of trap, it fits well into their system, they like the operation, but they want some repairability, now you're taking a look at like our TD700S. So it's going to have the integral strainer, you can add it with the blowdown, but it's going to have the replaceable capsule. So the whole disc and seat is going to be removable and put a new one in, and now you've essentially got a new trap. And that is inline field repairable. And then if you do get into some of the higher pressure ratings, 900 or even up to 3600 PSI, I don't think we've ever sold one in the territory, but that's where there's some other offerings to consider, TD900, TD3600. And then as Mark mentioned, general rule of thumb, great for drip applications and critical tracing applications. So we'll say drip above 30 PSI might be a good fit for a TD trap. And the reason for that is, as Mark mentioned, working off differential pressures and stuff, if you start to get excessive back pressure, that'll work against the operation of the trap. Enough so that if the back pressure exceeds 80% of the inlet, now you have the potential for that trap to remain closed and not operating.
Are universal traps later?
There's a little, there's a slide on universal. We can talk a little bit about those. So we talked about mounting in any position as a benefit, self-draining when installed vertically. Single trap operates over a wide pressure range. It's got the one orifice size in there up to 600 PSI, so you don't have to pick different orifices depending on the operating pressure within the system. Marginal or very poor at discharging air, as Mark mentioned, and then we talked about how the back pressure does affect that trap.
Yeah, so this is the one trap. If you have a factory or something and there's a common condensate return line, and you have 10 TD traps all discharging into that return line. One failed TD trap will pressurize that condensate return line, and all of the other ones will appear to be failed, because by pressurizing that and not having the differential, the condensate won't flash above the disc, it'll never close. So it's, I don't want to say it's hard to troubleshoot, but if you got into that situation, you now have to isolate every single trap and basically have a pressure gauge on the return line to figure out what's going on, because they're all going to look like they failed. So
Yeah, and I think the more that I talk to Mark and the other guys out in the field, and the more experience that I get myself, I find that TDs was kind of the always recommended above 30 psi, but we start to find, when you're discharging to atmosphere, that probably still holds true as long as the facility is okay with that instantaneous discharge. But as you start adding back into return lines, and we know over the years, the return side of things is never really addressed, so return line sizes stay the same, people keep adding more and adding more. You may want to start to consider thermostatic traps, or even though we say no to bucket traps sometimes, I mean, they sometimes seem to be a better solution than just always saying, yeah, go with a TD because you're above 30 psi. So there's definitely some things to consider there. When we talk about that instantaneous discharge of the TD trap, we do offer diffusers, really just a stainless steel body with a mesh screen inside. So if you're discharging to atmosphere, instead of having that blast discharge, whether it be for personnel safety concerns or just CEOs in a facility say, hey, I don't want it to look like that, just stuff discharging everywhere, that the diffuser will help to dissipate that blast discharge. And then also, if you're going into a return line, depending on how that is piped in, sometimes you'll see guys piping into the bottom side, which is a no-no, but in any case, they don't want to change that. You start to get some hammering or some shaking going on in that return pipe. The diffuser in that case could potentially be like a Band-Aid type of solution if someone doesn't want to go through the steps to actually do what's right there. Anything else to add on the TDs, or
no.
any
I think
questions?
they're more of a marketing. They work. They will fail quicker than an F&T trap or a bucket typically, because the bottom of the disc is a highly polished surface. The seating surface is highly polished. Any dirt and debris that ends up going into that trap, any little nick or ding on that disc, and it won't seat. You'll hear it psh, 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 sputters, and that means that the trap has failed. There's no way to really repair that properly. So, like Steve said, it's a throwaway trap. Once it's done, it's done. Whereas with an F&T or a bucket or something like that, pull the guts out and throw new guts in, you have a brand new trap.
Any questions on the TDs? Okay. So now we'll talk about the F&T style trap. So it is a mechanical type trap with a floating lever that really is the guts to the trap. I'll let Mark get into the operation, but just at a high level, you can see the float on a lever arm with a plug-in seat and your orifice, and just based on that condensate level in there and that plug coming off the seat, it's a balance of forces there and draining that condensate out and holding back that steam. You want to go through that?
Yeah, sure.
Just show them a little bit.
Yeah, so this would be the guts of an F&T trap. So this particular, the FWFT. So it is a float and thermostatic trap, so F&T. So during startup, we have all this air in the system. Air has to get pushed out, steam behind it pushes that air through the system. It's got to go out somewhere. We have air vents at the high points, but you're also going to have air trapped in your heat exchangers and piping in the lower section. So this air vent is just a filled thermal element, bellows, that expands when it's heated, contracts when it's cooled. So it'll be cooled when air hits it. Now it bleeds air, bleeds air, bleeds air until it sees steam. Now the steam comes up behind it. This thing senses it, says, wait, I see steam. I want that to stay in the system. The water alcohol mixture inside the bellows expands, closes that off. Now, this just goes like this. Condensate comes in, opens, and closes. That's it. They'll usually find a happy medium here. As condensate comes in, it opens. As it discharges, it closes. So, pretty simple. There's not much that can get damaged on this. I mean, really, the seat can wear out a little bit maybe over time, and the steam will pass through. It is susceptible if you have an overly dirty system. The orifice is kind of low in the trap, so you could get some gunk or dirt to clog up that seat, but otherwise it's a pretty rugged trap. All different versions. This is just the inline version of this. So this is also an F&T trap. One reason we made this, we don't love inverted bucket traps. People didn't want to repipe to go into the traditional FT. This has the same face-to-face dimensions. So if somebody has a bucket and they say, hey, this thing's not working great, well, we have an answer. And we can just drop it in and they don't have to repipe anything. There you go.
So some trigger words I'll say for the F&Ts, when you take a look at our FTT, which is that inline F&T trap, you might hear like a Spyrex Sarco FT14. That would be the crossover there. We do have an all stainless steel version of this now as well. So if you're not familiar, our FTTS for the stainless is our newest inline F&T trap. So if you've got food and bev, maybe some wash down consideration, or just something other than a ductile iron spec, maybe just a steel spec, you can consider the FTTS.
That should be pretty big for you guys, because before, a year ago when that trap came out, if you wanted a stainless steel trap from us, you were going to pay a significant amount of money. We have the FT601, which is an industrial stainless steel trap. But when I say industrial, I'm not talking food and beverage really. I'm talking refinery, chemical plant. So now that we have this lower cost version of a stainless trap, you guys should be able to kill it against, I'm assuming you're still selling against TLV out here. So, any of the food and beverage, any of the jackety kettles and stuff that require stainless steel, you've got the FTTS now, that's at a lower cost point and gives you an advantage.
When you look at the WFT, that 2-port parallel pipe trap, the Sarco FT series is going to be the direct crossover. So even 3/4 inch, 1 inch, 1 1/4 inch, 15 and 30 pound ratings, you can take that mechanism or that cover assembly kit that you have there in your hands and actually put that into a Sarco body. When you take off that 1 1/4 inch and you just look at 3/4 and 1 inch, you can actually replace across the whole pressure range, so up to 250 psi. And then of course, if you're just replacing the whole trap, it's got the same center to center dimensions, so it's a direct replacement, no piping modifications necessary. When we don't show them here, but when you get into other applications for it, maybe you want a 4-port H pattern design, you need some piping flexibility, obviously we have those to offer as well. So as mentioned originally by Mark, typically we find these on process applications due to the varying loads that you see and how this is able to really accommodate those varying loads. You can find them on drip applications. Maybe a facility is looking to standardize, in their inventory. And we'll get into a little bit on sizing drips. But the loads are fairly insignificant that you could pick a high pressure orifice, say up to 250, and handle all the different drips in the facility, whether it's the high pressure drip right off the main, or even as you reduce pressure at the use points, the lower pressure ones, because they're not generating so much load, the capacity on a higher pressure, smaller orifice would be sufficient. I think we talked about all the benefits and considerations there.
And you'll notice on the functions under high back pressure, so this particular trap would not be affected if one of the other traps failed. That differential pressure being reduced wouldn't cause this to fail, so, or at least appear to be failed, which is good.
And in the instance that you do have a facility that has some freezing concerns, whether it be outside, obviously you can see the body here, there is some potential to hold some condensate in there. I guess when the system's up and running, there would be less of a concern, but if the system is shut down or something and that water remains in there, the potential for some freezing and cracking. Now, most of the F&Ts that we do offer are going to have the ability to tap into it and offer a freeze protection valve. So we do have a solution for that if that ever comes up. Any questions on the F&T traps? Right now we're just kind of getting through the types and how they operate. So now you get into the thermostatic or the bellows type steam traps. Why don't you just jump right in to how it operates?
Yeah, I can't really show you much with this because it doesn't
You
open.
could show a little bit of
But
the
you can
picture
see it here. So again, this is this. This is the WT 2000, this is actually a 2003. So there's a couple different options. 2001 is a 3/16 orifice. Did I say that right? 2000, yeah. 2003 is 5/16 orifice, so a little bit higher capacity, bigger outlet orifice. So all this is basically the same thermostatic element that's in the F&T trap. So when air goes through it, this is cooled, the outlet orifice is open, air gets pushed out. When condensate comes, it's still cool enough, this remains open, steam pressure pushes that through. When steam comes up to it, about 5-10 degrees before it hits actual saturated steam temperature, this thing says, wow, I'm getting hot. Starts to boil off, expands, closes. More condensate comes in, this contracts again, opens it up, and just keeps going back and forth. Like the F&T, very good at air venting. It's got a very big outlet orifice, so the air can just kind of scream through it, unlike a TD trap or an inverted bucket. Really good for drip applications. The nice thing about this is, kind of like the TD, you don't have to select it based on your pressure. So this works 0 to 650 psi, this is 0 to 600, but this is not affected by back pressure. So you could just throw this in on any drip application at virtually any customer you have, and it would work fine. I don't know if there's any. It's not repairable. This is a kind of a repairable version, similar to the F&T and the TD traps. There's different versions. Non-repairable, repairable. So this is the non-repairable throwaway. This would be the repairable. 4 bolts, take it out. You can replace the bellows and the seat and do an inline repair. Most people, in my opinion, are just buying these and tossing them when they're done. You're going to get a good probably 3 to 5 years out of these anyway, at least. So should be all right.
Yeah, and so the WT 2000 series also good for non-critical tracing applications, whereas a throwaway drip. The cast iron WT 2500 is rated up to 250, but we still have like a WT 3000 if you want that stainless steel repairability. And then the 3003 and now even the 4000, the WT 4000, you get a little bit more capacity out of them. So you're talking now lighter process loads, maybe on jacketed kettles and things like that. Now, as Mark mentioned, when you talk about the operation, that backup of some condensate based on subcooling, that's a consideration, right? So you always have to kind of know what your pipe volume is upstream so that you have enough or sufficient amount so that if it does back up, it's not backing up into your process or into a main header off of your drip or something like that.
And this is also one of the nice things. So when it says excellent for drip applications when flash steam is a concern, because of that subcooling. So let's say you have a 100 psi system, which is 338 degrees. Well, this is going to back up condensate just slightly to cool that condensate a little more. And what does that do? Well, when that condensate finally discharges and goes into the return line, you're going to have less flash steam because of that differential is going to be a little lower. So if you have problems with pinging and banging and shaking in your return system, you may want to think about a thermostatic trap, maybe even a thermostatic trap with a higher subcool so that it can even cool further to allow for less flash steam to be created in the return lines. And this goes back to what Steve said. Somebody had a 3-inch return line back in 1950 when they built their facility or hospital, and they built an 8-story tower and another wing and then this wing. The return line's still 3-inch. So they're just shoving all this stuff into the same piping, you end up pressurizing it. So the more you can help get that condensate back into it without creating problems, you're better off. So.
We talked about that, being able to operate in any position, freeze-proof when installed vertically, everything else we touched on. Any questions on the thermostatic trap? Good. All right. Stay with us here. We're on our last type of trap that we'll talk about, and then we'll get into some sizing. So now we look at inverted bucket traps, once again similar to an F&T in that it's a mechanical trap in design. It's got a bucket with a lever arm, small little orifice up top here for venting air. Mark's gonna get into how they operate. It's a very rugged trap, simple in its design and operation, and that top-mounted orifice makes it a little bit less susceptible to dirt and debris clogging up that orifice and causing the trap to fail prematurely. Now, this is the only trap that does require a water seal or a prime, and Mark will talk a little bit about that. So that's a kind of a drawback or consideration, and why we wouldn't recommend these on process or varying load applications, maybe constant high-pressure drips.
Yeah. So the reason this needs a prime, like Steve said, is you can imagine if this bucket was not filled with anything, this is all it's going to do. It's just going to sit there. So if you just turn the system on, steam's probably just going to start shooting out of the outlet of this. Eventually it'll build up a prime, but initially it'll appear to be failed. So once you have a prime, which all it means is a small level of water inside the bucket floats because it's got air above water and the thing floats up. So, no, of course, this thing always breaks when I'm messing with it.
I'll give you a courtesy credit on that.
Yeah. Yeah. All right, screw that thing. So once you have your prime, what do we have in the system? Like every other one I talked about, you have air to start. So you've got air in the system. This bucket is in the up position or the closed position. Air is in the top of the bucket. It's going to bubble through that water seal. And the major issue with inverted bucket traps is its ability to vent air. The floating thermostatic trap had that thermostat that really shot air out. Thermostatic trap, same thing. There's your air vent. So it's a little pinhole on the top of the bucket. It can literally take hours or days for a system to start up with an inverted bucket. Not all the time, but it can happen. So that's a consideration, is long startup times, long heat up times. I know food and beverage guys do not want to wait 4 hours for a jacketed kettle to get hot so they can start cooking their soup or doing whatever they want to do. So that's a consideration. Steve also mentioned the loss of prime. So if this thing has erratic pressures or fluctuations in capacities and load, you can actually boil off this prime, and if you boil off the prime, the bucket drops and it fails open. Also not a good thing. Steve also mentioned, unlike the F&T and all the other traps, the outlet orifice is completely out of the flow of where dirt would end up. So if you know you have an extremely dirty system, a lot of laundry facilities use these. Really anybody that knows they have a dirty system, or at least admits that they have a dirty system, because nobody does. All the dirt and debris will collect down here at the bottom, and then the outlet orifice is just completely protected from that getting clogged up. Other than that, I don't think they're a bad trap. I just think an F&T is a better option, for the customer. So,
But I'm sure you come across those customers that they've had the bucket traps installed for quite some time, don't want to change, they're familiar with them, they're comfortable with them, they haven't given them issues. Hey, we have an offering for you still. So do you guys run across like the Armstrong 800 series a lot out this way, or a little bit?
Now and then.
So our 1030, 1040 series is going to be a direct replacement for that Armstrong 800 series. So much so that you could take that pressure change. Yeah. You could take that pressure change assembly kit what Christine's holding there and actually put it right into an Armstrong 800 series trap if you're just looking for repairability that way. We have a stainless steel option as well. And then, as Mark pointed out way back in the beginning, many different options for these types of trap, whether it's larger, physically larger traps for higher capacities, integral strainers. We talked about poor air venting. Maybe you do have customers that don't want to move away from a bucket. We do offer some thermic vents to maybe try to help that situation out, try to get rid of that air a little bit quicker, and then even integral check valves as well. I think we touched everything there. Once again, it's not self-draining, has that body has the potential to hold some condensate in there, so just consider any freeze protection if needed. And like an F&T, it's got a properly sized orifice, so just making sure you're picking out the correct pressure ratings it's not gonna work across the whole pressure range, say like a TD or a thermostatic would. And now we're gonna get any questions on the bucket traps, or any of the traps we talked about? So let's get into some of the sizing and selections of these steam traps. We got about 15 minutes or so left. So typically some information that you're gonna wanna require from your customer is that inlet operating steam pressure, and then the outlet pressure or the back pressure on the system. So if it's, if it's discharging to atmosphere, theoretically 0, or if you're going into a return line, okay, do you have a gauge on that line? What is maybe some pressure we have built up in that line? So we'll talk a little bit more about some of that. And then, condensate load, in pounds per hour, what does this trap need to pass? If it's a drip application, we're gonna walk through that. Sometimes can be a little bit insignificant in that you're probably just gonna say,
I'm not gonna touch it.
give me a 1/2 inch or 3/4 inch trap. You pick the trap type you want based on all the things we just went over, and then just move on. I see, Mark probably see this as well. Far too often you see folks just like racking their brain like how to size or select a drip trap. You're putting too much thought into it really at that point. And then really, once you get outside of the sizing of the trap, that's when you start to get into, all right, what kind of connections do I need? Are there any material specs in a facility? That's what really maybe will drive you to the exact trap that you want, aside from the type of trap.
The most important thing probably on that slide is the bottom. So for inside salespeople, when a customer calls and says, hey, I need a TD 600, don't just say okay. You say, well, you need a strainer and a check valve, and you guys sell isolation valves, I'm sure. You should sell all the other stuff that goes with it. So it's, do you want fries with that kind of routine? If we have it, you have access to all these different accessories, they got to get them from somebody. Make sure that you're offering everything that goes with that product.
And if you're selling check valves on an atmospheric discharge, Christine owes you an award, that's for sure. So we talked, as Mark went over the operation of the traps, really what it comes down to is that differential pressure and being able to push that condensate through the system. So we're going to look at different types. Let me just get right into it. So discharging condensate to atmosphere. So you can see in that picture there, we're working with 50 psi steam pressure off the main header into our drip leg and then into our trap. So we've got 50 psi on that inlet side, discharging to atmosphere, theoretically 0. And that's how we're going to size that trap, because when you look through our charts, hopefully everyone's got full catalogs available to them. There's a couple on the table. But here's an example of a chart. I'm going to go right over to 50 psi differential, because you have your 50 psi minus your outlet of 0. And I'm going to use the capacities in that column to size my steam trap. And we'll talk about safety load factors and warm-up loads on drips and things like that as to what number you should be using there. Discharging condensate to a gravity return line. So in this situation again, 50 psi on the main steam coming to the drip leg into the trap. Now theoretically, in a gravity system, the condensate will be able to get to our vented receiver shown here, venting to atmosphere. Hopefully everything's been properly sized, that it would theoretically be 0 as well, as shown in the pressure gauges. So once again, 50, 0, total differential of 50. The thing to consider here is, as we've talked about, adding things to a system, things start to become undersized. How is this back pressure affected by that? So it's always nice to have those windows into the system and have those return line pressure gauges, because as things start to get shoved into the system, or maybe some traps are failing throughout, you might actually start to see, even though it is vented to the atmosphere, you could potentially see some creep up of pressure, and now that could change our differential. It might not be significant to where it's going to change the trap size, but certainly a consideration.
People always have pressure gauges on the supply side. They never have pressure gauges on the return side. But you guys should start selling pressure gauges on the return side. It would help us out big time.
Yep. And then the last type of installation we're going to look at here is sending that condensate to an elevated return line, or one that already has some pressure. And we show actually both here. So same 50 psi steam main coming to our drip leg into the trap. But now what we have here is an elevated lift of 23.1 feet. Out in the field, we just say, every 2 feet is 1 psi, even 2.31 feet, but we'll just we'll just say for quick reference, 2 feet. So we have 10 PSI of head pressure here already working against us. Plus, our gauge shows us we have 5 PSI in this return line already. So now that's not always the case, that's just as an example, so it's definitely something that we have to consider. So really you're looking at the total back pressure, that lift plus any return line pressure. So now we've got 50 PSI on that inlet, but a total back pressure of 15. So now our differential sizing is different than what we saw earlier on the 2 other installations. So now we're coming towards the left on the scale here, in between that 30 and 40 PSI differential. So you can see now we're talking, you know, insignificant here, but you can see how the capacities change based on that differential pressure. Any questions about the different types of installs? Okay. So when looking at drip traps, some general rules of thumb. We like to say every 150, 300 feet of horizontal piping, at every elevation change, before every critical component. If you're using a steam separator, obviously off that separator, and then at every end of main, there should be drip traps to give us the most efficient steam system possible. So, Mark, you want to talk a little bit about sizing of drip traps off of main headers and how maybe insignificant some of that becomes?
Yeah, I mean, this is less of a mathematical kind of lesson here and more of you don't have to size drip traps. This is kind of what we're getting to here. So we're taking an example of an 8-inch main on 100 PSI steam, and we're going to have traps placed every 200 feet. So just picture, you know, a 1,000-foot long piece of pipe, and every 200 feet we're going to have a drip leg and then a trap on it. So warm-up load is the safety factor. Why does it say that? Well, under normal operation, under running load, we have much less condensate formed in drip traps or in the mains than there is in startup loads. Why is that? When we start up a system, the pipes are cold, everything's cold, so you're going to create a lot more condensate during startup. So even when taking that into consideration, so let's say we're going to size our drip traps based on startup load because that's basically a safety factor. That's worst case scenario is I have freezing cold pipes and I'm putting hot steam down them, so it's going to create a lot of condensate. 8-inch main, 100 PSI system, you have 100 pounds per hour of condensate created every 100 feet. Well, we're going to have these traps every 200 feet, multiply that by 2, we have 200 pounds per hour that we have to size that drip trap for. Insignificant. It's even less if we have a system, if you guys have customers, where their system is just running 24 hours a day, 7 days a week, 365, they shut down once a year, you can just size it for this. But the point is, I don't know if there is a point, but there is a point. You can see at 100 PSI, our half-inch TD 600LS-12-N, that is literally the smallest thermodynamic trap we have, is grossly oversized for even that 200 feet of pipe, 8-inch main, 100 PSI. You hear 8-inch main, 100 PSI, 200 feet, you're probably thinking, man, we're probably going to need a pretty decent sized trap. Nope. The smallest one we make is twice the capacity that we actually need. So really what this is saying, if anybody calls you and says, hey, can you size up a drip trap for me? You don't have to. You can literally sell them a 1/2 inch or 3/4 inch high pressure, so that L is the kind of low capacity, but the high pressure traps, and it'll be more than enough for any drip application that you need. So really, no need. You have to size up your process traps. You do not have to size up your drip traps.
And in the full catalog, we do have a quick reference chart on page 28, along with the other charts that are used up here, right before that, just giving you some guidelines on, hey, my operating pressure is between 30 and 150, what am I looking at, 0 to 150, I mean, just giving you all different types of options to look for on the drip traps. If you do have a customer complaining of a drip trap not having enough capacity and it's been determined that the trap is working, Now you gotta take a look, take a step back and, ask yourself or start talking to the customer about, all right, well, when was the last drip trap? Let's take a look at the piping design. What does the insulation look like? If it, is there excessive, could there be carryover from the boiler? So it's usually not the sizing of the drip trap, there's something else going on. That needs
Yeah,
to
the
be
drip
addressed.
leg's too small.
Right.
You know, on an 8-inch main, which is about yay big, if somebody's putting a 1/2-inch drip trap on that main, the contractor might say, oh, 8-inch main, I got a 1/2-inch trap, I'm just gonna tap off with a 1/2-inch connection off the bottom. Well, how much is a little 1/2-inch pipe gonna collect when 100 PSI steam going 70 miles an hour is running down the piping? Nothing. So that trap could be perfectly fine, but unless that drip leg on the bottom of the pipe is big enough, you're never going to collect that condensate.
Yeah, page 26 will show you proper drip leg design, the half pipe size up to 4 and so on. So we're not going to get into that, but if anyone has any questions, please feel free to ask. So taking a look at a typical F&T capacity chart, the one thing that we talked about earlier is having to pick a specific orifice for your operating conditions. So when it comes to drip applications, this is where we talked about maybe standardizing so that you're not having, you've got your high pressure drip at say 100 PSI, then I'm knocking down medium pressure 50 PSI, now low pressure maybe 15 at the point of use. Someone might go through this and say, oh my goodness, I need to get, 3 125 pound traps, 375 and so on, and it's some low pressures. Really when you talk about the small loads of the drip traps, or the drip legs I should say, you can see here that we can actually just pick, we can standardize on a higher pressure orifice. So like in this case, at its peak here, 100 PSI, 1100 plus pounds per hour. So you can see that that's certainly sufficient. Now we get into, let's just go all the way down to our low pressure. Even our 125 pound small orifice at 3/4 inch, we'll call it 50 PSI differential, 500, a little over 500 pounds per hour. So that gives us the ability to standardize on an orifice so that there's not confusion, all right, now I've got my shipment from IPS, I've got all these different orifices, hopefully someone's not grabbing a 15 and throwing it on the high pressure side, now that thing's shut. So, once again, we're talking drip traps at this point. All right. So, just to kind of recap a little on the drip, so anywhere from 50 to 400 is a typical load off of a drip leg, and then the process, we'll get into sizing that now. That's when you get into the larger 350 all the way up to 20,000 pounds per hour. Like I said, there's a drip leg design in our full catalog, and then just general rules of thumb that we would use for drip applications. Under 30 PSI, 1/2 inch, 3/4 inch F&T trap. Above 30 PSI, 1/2 inch thermodynamic with the smallest orifice available, if possible. And then consider some of the other things we threw at you. Maybe a thermostatic's better fit, maybe inverted bucket depending on your customer preference and steam system. Any questions? Looks like we're running short on time here, but still good? Okay. Real quick, taking a look at universal connector style traps. Is everyone pretty familiar with these types of traps and how their benefits of having a connector with a 2-bolt trap module design?
Do you guys sell any of these? Do you get any
Not very
requests?
often. We get, I think there's a couple customers that request it, but there's not many. Yes.
It's at this point it's usually an upsell in that it's great for the maintenance guys, and as far as convenience and being able to take off those 2 9/16 inch bolts instead of breaking unions and things like that to replace a whole trap. So it is a little bit of an upsell up front, pays itself back over a couple replacements, I'd say. But just know that we do have the offering, and we've got all the different trap types to go across the trap modules there. So thermodynamic, thermostatic, F&T, inverted bucket. We even have, and we don't show it here, now we have these connectors with integral isolation valve, strainer, blowdown, and test port as well. And even now they've added an integral check valve into that connector. Now these are meant for drip applications. The trap modules don't have really high load capacities, so they're really meant for drip application. Maybe you can touch on some lighter process, but typically on drips is where you're going to find these. We talked about some of those French fry adders in the steam system, certainly separators to help knock out that moisture in the system. It's gonna be one of those add-on features. And then off of that, you would have, you know, a drip trap. Once again, strainers upstream, whether they're integral or not, strainer upstream, check valve downstream when discharging to a return system, and then considering diffusers for especially thermodynamic type traps, or really any type of trap. You guys get into any collection manifolds, steam distribution and condensate collection manifolds for chemical plants or anything like that? I don't
Very
think.
seldom, very
Okay.
seldom.
Okay, so we won't touch on these a whole lot then. Just know that we do manufacture our own forged manifolds for steam distribution side with integral isolation valves. And obviously, we're gonna package that together with steam traps, and then the return side of things as well. All right, before we jump into this, looks like we're running right on 12:30 here. What can we condense here to help you out?
I think you can go another, can you do it in 5 or 10?
Yeah, well, we can gloss through it, yeah.
That's okay.
So I'm gonna, excuse me if I kind of go over the slides here, I do want to make sure I get some of this in here. So when you take a look at sizing for process traps, so Mark went over how to size the drip traps. General sizing for safety load factors on process applications, there's kind of 3 main things when looking at this. First being, do you have any sort of modulating control valve? You know, in this case, we'll talk temperature. If you do, and you have sufficient pressure, I'm sorry, let me take a step back. If you don't, then it's just simple, 2 times max condensate load. That'll be your safety factor. Based on your differentials, that's how you're gonna size your process steam trap. If you do have a temperature control valve and over 30 psi coming to the inlet of that control valve, now we're gonna say take your max condensate load and multiply that times 2.5. And then lastly, and certainly the most conservative, even if you just, you know, if you wanna go this route, would be control valves seeing less than 30 psi. Well, let's take that max condensate load, don't throw a safety factor on it, but size it using that half psi differential column in the sizing charts. And we'll go through some steps here. So in this example here, we've got a steam load to our heat exchanger, 855 pounds per hour. And we're gonna size that trap for a full load at a half psi differential. Let me take a step back here. What's that?
I was gonna say.
Yeah, I
see
need
what
some
pressure
conditions
was
here, yeah. All right, so it looks like in this example, we have 40 psi coming to the inlet control valve, 20 psi to the control valve, and that's 50% drop off of that control valve. We're getting into, we talked about head pressures for traps, and going into 0 psi of back pressure. I don't want to get into all the calculation stuff, but obviously you can see we're working with 855 pounds per hour. So now when I go back, so we have that modulating control valve. Now that showed 40 psi to the inlet. I told you under 30 psi. But in any case, it looks like we're going to be sizing this off a half psi differential. So what I want to do is go down this chart here, find something that's going to meet that 855 pounds per hour at a half a psi. As I go down, it looks like to me that the 850 is going to be the closest. So I can actually pick the 1.25 inch or even the 1.5 inch WFT 075, which is that 75 pound rated trap, and use that for the system. You know, I wouldn't pick, say, the 1.5 inch 30 because I have 40 psi of the control value, even though I said I had 20 in the system. The potential to have more in that system could be greater than 30, so I wouldn't want to pick that trap. So it looks like my best option here is going to be the 1.25 inch, 1.5 WT 75. Now you can oversize steam traps, so it is always best to try, after you've calculated your safety load factors, it is always best to try to pick a trap that's going to be right at that capacity. Let's see what we have. So just some general rules of thumbs for process traps. I don't even think we need to go through this. I mean, we talked before about, you know, when you start getting into end connection types, piping configurations, the material specifications, that's probably going to differentiate which trap model you're going to.
you'll see the WFT 90% of the time. Like I said, you'll see the FTE, which is the high capacity on heat exchangers. And then for food and beverage, there's a picture of the FTTS there, the stainless. Those are probably the 3 traps that you're gonna sell most of the time. And the only reason you'd sell one over another is either material construction or capacity. That's it.
So there's just an example of a typical heat exchanger when draining by gravity. You can see we've got our steam trap there. Likely have a vacuum breaker and an air vent set up on this. And I think what we're going to get into is what happens when you throw a modulating control valve, take the vacuum breaker off, and start getting into system stall. And now we're looking at pump trap combinations. So how familiar are you guys with pump traps? Not a whole lot. You're familiar with the selling steam traps on heat exchangers or process equipment, correct? So typically typically I'd say there's always some sort of modulating control valve on these systems. It's just a better operating system that way. So when there is, and you run the risk of when the system is satisfied, that control valve closing off or coming back down to its close off point. Now we might not have enough pressure to push that condensate through. We talked earlier on about pressure pushing condensate through, whether it be gravity or into an elevated return line. You've got to have some sort of positive differential. So if that system starts to close off, and now we don't have that positive pressure, now we get into pump trap combinations. Let's see. Something similar to like our PMPT, offered as inch by inch check valves, 1.5 by 1.5 or even on higher capacity load, a larger pressure motive pump with an external steam trap. I can say we solved a ton of problems, system problems, by offering pump traps. We'll go out into the field, we'll see a heat exchanger, has a steam trap on it, lifting to an elevated return line with some bad pressure, and a control valve on it. And complaints of erratic temperature control, backup of condensate. Definitely consider a pump trap combination. And even just once you add a pump trap to these systems, you can see here we have an air vent, but we no longer have a vacuum breaker. A lot of times, so many safety factors have been applied on all the components throughout that everything is oversized. So you'll find, especially on normal demands or lower demands, these systems wanting to operate in vacuum more efficiently. And the pump trap will allow you to do that. It'll always be draining that condensate out of the heat exchanger. I know we're glossing through this a lot.
We also have a stainless steel pump trap. So for your food and beverage applications, we also have a full stainless steel version of that. I think TLV had one, didn't they? You don't remember?
Yeah.
I think they're the only other ones that might have a stainless one. I mean, it's price-wise, it's night and day. We'd kill them on price, so.
All right, we're 5 past here. Any questions on what we went over?
What do we say to a customer who's wanting TLV or Sarco to sell them on what you can?
Price, domestic manufacturing, factories an hour away. Steve and Mark are pretty cool.
Oh, I think that's the lead thing.
Yeah, I mean, they're gonna have the same operation, domestically manufactured for less cost, with probably better support, because we have a bigger team locally, I think, to support it. So.
Did you mention lead time? Sometimes lead time comes up. Obviously, we've got $9 million in inventory. You guys have your own inventory of this stuff, so that comes up when out in the field. Yeah, definitely price, I hear.
Believe me, it's hard to fight the names. Nobody wants to make that decision, and at some point you just have to say, okay, because, I mean, in New Jersey, near Trenton, we have a distributor that they offer lots of McDaniel over Sarco every single day. No one wants it. They say, we want Sarco. They go, well, it's 50% more expensive. We don't care, we want Sarco. No one wants to make the decision. Even you go from a TD52 to a TD600, which is the same exact trap, if that thing fails, that guy loses his job or whatever happens, and nobody wants to make that decision. So I would say it's more a matter of your customer just trusting you guys that you're giving them the right product. I mean, I don't know.
Traps,
We-
yeah, traps have become
If we had
such a
that answer,
commodity.
we probably wouldn't, we'd be selling $50 million worth of product in the Northeast, so,
Is there a conversion chart in the catalog or
Yes.
online?
Yeah, so a couple of resource type things. Do you guys have the quick reference crossover guides, front and back laminated?
Pretty sure we do. I think we have some downstairs. We might be able to get some more, but
Okay, yeah, we'll take a look at that.
we used to.
If you're in the full catalog, we have 8 or so pages of comprehensive crossover guides. So like, you know, I'll reference that TD52. A customer calls in, one TD52. Hey, how about you consider Watson McDaniel? The chart will show you that. It shows you that for traps, regulating valves, condensate pumps, even some skid systems. Has anyone been out to our new website? So it was launched about 2 months ago or so. Now that doesn't really have a whole lot of crossover information, but what you will find is some sizing help. So it's set up kind of like the McMaster car website is, if anyone's been out there.
you
So,
online?
might be, I'm not sure. If you go to, let's just pull it up here to see. There you go. So this is what it,
Lot nicer than
Yeah.
it used to look.
a lot nicer, a lot less static. It's actually got some scrolling, informational screens. It's got all the product on there. We didn't even have some of the product on our old website. But if you know what you want, and you go right to, the product section of a steam trap. Let's go through this way. Excuse me. You can see here your filter selections on the left-hand side. So if you already know kind of what you want, you can simply filter by size, connection type, option, strainer blowdowns, and it's going to spit out exactly what it is that you're asking for. We do have some simple sizing help here. This is kind of the simple version. If you know your inlet pressure, discharge pressure, it'll kind of spit out that differential, maybe the capacity or the condensate load. Plug that in, and now we'll give you the different trap types that are available to meet those conditions. Or you can even get into, if you go to this calculator here, you can get into more comprehensive sizing based on your applications, drip traps, heat exchangers, etc. The same could be said for pilot operated regulating valves. We have a whole HD series configurator system. You can size condensate pumps, the inlet and outlet check valves. So a lot more features. Of course, you can still pull down, all the PDFs, IOMs, cut sheets, everything you're going to need on our product can be pulled down off this new website. We're even adding.
Even the return forms are there.
They're there, yeah.
It's much more streamlined.
And now we're starting to include like 3D models. So we have the 2D models, we always have. 3D models you can find on the website if they're in our archive. So definitely a more valuable, user-friendly tool.
Are you guys asking when you're seeing Sarco, you're asking the customer if you
Oh,
can
yeah.
switch them all the time?
Bulk of the time. But it's
Yeah.
like you have those ones that they just won't, when it comes over for a quote. They ain't gonna budge.
I think from our standpoint, we just have to continue to pound away
Yeah.
at that, well, here's what you asked for. Here's a less expensive alternative with a quicker lead time. On the instances when it's a new application and it is something where here they have engineers involved and they specifically called out something, we can call you guys to try to get in contact with that engineer to get you put on the list.
Sure.
Yeah.
Okay.
Yeah, and then so one of the things that we've been tasked to do locally in this Northeast and actually just across the country is we're sending Greg Lehman, our Director of Engineering, out on engineering calls with us, so with Mark, myself. And these are things that we've done as well over the years. It's just, the limited resources, sometimes you can't always hit them. So now we have a direct approach to try to go out to these engineering firms to try to help you guys sell the product, right? So that when you get a spec or something, you see Watson McDaniel as the basis of design. So we've really tried to go out, really at the start of this year, that's been a big push of ours. That's going to take some time. It's going to take a few years to really get that going. But hopefully what I've seen a lot is like an approved equal type of situation. So yeah, it might say Spyrex Sarco, but It may also say, or approved equal. And even in cases where it doesn't, because we're starting to forge these relationships with the engineer, a lot of times, you know, we'll pick up the phone, hey, I got an opportunity here for a project. If it goes through as Watson, will you approve it? And more often than not, I've heard, yeah, we'll definitely work through it. Because, you know, at the end of the day, a lot of this product, regardless of the manufacturer, is pretty comparable. So yeah, to answer your question,
Yeah.
absolutely.
One, and I've always found that it's when it's the contractor bidding out the job, if you can show them cost savings or something, it's going to behoove you to quote the Watts McDaniel, because you can show them, hey, you know, you're going to have something over your competitor when you're quoting the job. Then it's the maintenance guy who doesn't want to, you know, switch.
Someone change.
Yeah, so
someone
when that happens, I
business.
think we just gotta get the outside salesperson in, and even getting Watson folk in there as well to try to talk him into it. So those are the,
Do you get emailed a lot of plans and specs? Do you guys have, you know,
More
plan
than we
rooms?
want.
we basically been telling customers that we'll help them as much as possible, but they're responsible for telling us what they need. You know, when it comes to drawings, we'll try to say, hey, this is what we think, but we push the responsibility back to them. We usually like them to have a list. We'll look over the drawing, you know, that's all well and good, but there are some customers that say, here's the drawing, and usually we just try to push back and just say, well, we need you to tell us what off that drawing you want us to quote.
Right.
Yeah,
'Cause
we're
we
not
don't-
engineers.
Yeah, we don't want to miss something. You know?
I guess maybe a better question is, do you have a list of 5 engineering firms that you see a lot that are doing work at all the different end users that you work at?
No.
No.
No, usually we don't hear much from the engineering firms at all. It's usually the,
Sometimes the drawings have that
Yeah,
information. That would be
yeah.
good information. for
Because
us
then
to
you can
start
feed it to
gathering.
us, and then we can work the back end and just get it specified, and then we don't even have this.
Right, you probably have like a Barton Associates.
Yes, that's
yeah,
one.
So yeah.
Yeah.
That's a big one.
Yeah. And then you always know we're a phone call, text, email away to help you.
Who's our competition that also sells Watts McDaniel? Anybody?
Jaeger has it.
Jaeger
IVRI
has it.
has it.
IVRI has access to the product line. Who else out this way? A little bit Cooney Coil, they have a sales guy that runs out this way, but I think he's always saying he can't sell it because he's up against you guys, and you guys have that more long-standing history out this way. Other than
You're gonna
that,
get a little Wolseley coming up from Maryland.
that's new. Yeah,
That's new. So they literally play right in York area.
Have you seen that at all with them bringing sales guys up this way?
Not
Wolseley?
Wolseley,
Ferguson,
it's
Wolseley.
an
Oh,
industrial
Ferguson.
branch of Ferguson.
Yeah.
So they're now up this way playing. I think even DS Pipe from Baltimore is up this way playing. I mean,
I've been hearing about them more and more.
Have you?
Who's that?
You
DS
haven't
Pipe?
let me know that.
people are coming up, other people are going down. I mean, it's just becoming one big.
One big happy family.
And it's hard for manufacturers because, you know, we have you guys set up here, we have DS Pipe set up there, and it's like, all right, just play in your little areas and be happy, and then everybody just starts fighting. You know.
That's why we have to sell ourselves,
Right.
along with the product.
Yep.
Absolutely.
Because we can sell better than
And use us.
IBR.
You know, bring us into the accounts and let us do the technical talking. You know, get the opportunity, make sure you qualify what you're bringing us in to see, and then, you know, let us just woo them with our steam knowledge.
Yeah, we've had some situations before as well, like, I know what rings a bell is Jim Mummert and Joe P going into certain accounts and having that long-standing history, and really, those guys are really Jim crossing over from one manufacturer to Watts McDaniel. So we want to make sure you guys are taken care of in those instances, and that if someone else is trying to sell in there, or someone else is trying to pull us into those, we take a step back and say, hey, we're already in there with, so-and-so. please respect that. And we do watch a close eye on that. I know there's, Christine, we can talk, outside of this, but we do keep a close eye on those types of things, because it's not in anyone's best interest for, people just to be cutting margins, and, it's not good for anybody. It's not good for Watson, it's not good for Acta, it's not good for, the other folks as well, so.
Okay.
If you're promoting the product line and bringing that awareness to the marketplace, we're definitely gonna make sure you guys are taking care
Repeat that at the outside,
Yep.
since I won't be here to ask
of it. No, I will, yes.
any questions that need answered.
Yep, no, we'll bring that stuff up, absolutely. What else
All right,
we got?
thank you.
Everyone get enough lunch?
Thank you.
Good? Okay. Appreciate the time. Hope everyone has a nice holiday weekend.